So it's with great anticipation that I will ask you to put your hands together and give a warm Austin welcome to Dave Ratt.
All right. All right. Watching some of the presentations earlier, and in talking about this ahead of time, Andrew and Alex, everyone here deals with a lot of really small things. I deal with big things, big, huge rock and roll sound systems. Didn't always start that way. Kind of meander through some of my kind of where I got to how I am, or how I got to where I am, and some of the observations along the way and things I've done to try and deal with them. Our sound purpose, what do we do with sound? I mean, whether we're doing a rock show, a house of worship, a political speech, or producing a record, or putting together a sound system in a club, we have this sound purpose. The goal is, as I see it, is to connect the artist with the audience. We have someone who has something to say, and we have someone who hopefully desires to hear that. And in order to do that, we want to maximize impact. We want to immerse as many of the senses as we possibly can. If we can grab their ears with sound, but at a rock show, we've got video, lighting, pyro. You've got the senses of the infrared waves from the pyro. You've got the sweat, the smell, the feel, and being pushed around. And the more senses we can immerse, the more memorable that experience becomes. And that's truly our goal, is to create something memorable, something that sticks with us, clings with us for the rest of our lives, something we share with other people in a common group. And sound is quality sound. It's so mysterious. It can actually, the quest for quality sound can inspire the most logical, regimented people that think normally into these audiophile realms where they're buying $1,000 power cables and putting bricks on top of amplifiers. There's this weird mystique that takes people over the edge from reality into this surreal world. And the opposite of that, the measuring of sound, where we begin to look at this high quality measurement equipment which we rely upon in order to determine whether or not something is an improvement or has issues. And we begin to rely on this measurement equipment to give us accurate information. Yet the measurement equipment will tell us that a pair of headphones is going to sound almost exactly like a pair of speakers. The specs will come up similar, if not. And so then we have to go back and rely on our ears. And because we rely on our ears and we have doubts in the measurement, or the measurement equipment that we have doesn't tell the whole story, it creates this mystique which allows the audiophile world to exist. And most interesting, sound has a power over us, something primal. We can listen to music, it can make us happy and give us comfort. It can make us angry, it can make us scared. And that is where this connection comes from. And I think that's what motivates this desire to push sound to its limits. When I was 15 years old, I was the kid huddled by the stereo listening to headphones. I had these AKG K240 sextet headphones with a single driver and 6 passive radiators, all tuned at different frequencies around the outside to give this ambient sound that was both direct and clear and open to make it sound like it was real to me. And I remember getting Crosby, Stills, Nash & Young 4-Way Street album and trying to pick out each of the guitars on the album, and trying to figure out who was playing which, and trying to place them in space. And I got the Cars album when it first came out, and I remember dropping the needle on there and hearing Life's the Same when you're moving in stereo, and that when the vocals, that comes and starts panning from side to side. And the contrast between the two, one, a capture of a real-world experience of a band playing live on stage, and the other, new wave, this total synthesis of something that can't exist in real life. And at the time, I worked at Winchell's Donuts. From 12 to 4 a.m., I would save some donuts from the day shift, and there was a homeless guy that would come by, and I'd give him free donuts in the wee hours of the morning. And one day he shows up and he says, would you like to buy a hookah? I was like, ooh, and he's got this blanket wrapped around this object. I was like, I didn't really know what a hookah was. I said, let me see it. And he opens it up, and there's this hand-carved, rose-colored brass bowl with tubes. Like, how much? $5. And he's passing the hookah through the window of Winchell's with the blanket, and I hide it behind the flour sacks. And on the way home, as I'm scraping the donut grease black lines off my shoes before I get to the house, oh, my dad's not going to be near as excited about this hookah as I am. And so I hide it behind some bushes, and the next day I get up. I can't wait to tell my friends. I'm like, oh, look what I got. I got my new acquisition. And I didn't realize it at the time. Well, I haven't got there yet. I'm getting ahead of myself. So I go to these guys' house, and these three guys that live there work at Phillips AKG, and I show them the hookah, and they're like, how much? We got to buy this thing. It's like, oh, no, this is my new exotic. And he said, would you trade it for some microphones? Some microphones? Let me see them. So they pull out this box of mics, and in it's like, they're like gems to me. They're nickel-plated brass and little screws and these little dots of metal all welded together like those old AKG grills. Oh, they were gorgeous. They had these strange 3-pin connectors I was unfamiliar with. I left there with 5 microphones, 2 of these AKG D200 two-way. They had a woofer and a tweeter inside the mic and a crossover. And I didn't realize it at the time, but it may have been a turning point in my life. So I go home and I listen to my voice, and hey, yeah, woo, and I'm talking in my headphones, and I record my voice and I play my voice back. Oh, wow, you really don't get the same thing when you hear your voice. You sound much better to yourself than you do to everyone else, I realized. My second powerful sound memory was up the street while I worked at Winchell's. There was a church, and in the church, a bunch of hippies made art in the front. And I was like, I'd go there, but I didn't hang out with them. I went to the back where all the punk rock bands rehearsed. There was a band, Black Flag, and Red Cross, and Minutemen would come and visit. I would go back there and hang out with these guys. Now I have these microphones. Hey, check it out. I got these microphones, a cassette deck. And I recorded some of the rehearsals, and they said that I worked out a deal where they would put me on the guest list, and I would bring my mics and my cassette deck down and record their shows, and they put me on the guest list, and make them a copy of the tape, and they put me on the guest list again. So I'd go down to the show, and I get the gaff tape out, and I tape the microphones up to the ceiling of the club and run the mic cables that I now had out to the cassette deck nearest power outlet, hit record, and I'd be all excited and run around. I'd be jumping off the stage, and everything would be all sweaty and cool and exciting. Mics sometimes would fall off the ceiling because the duct tape didn't work that well. I lost a few of the mics that way. And then I'd get in my car, Toyota Celica, I'd put the cassette deck in, I'd hit play, and it's all far away, honky, the high end, all that excitement was gone. Where'd it go? Somehow something got lost. I could hear the band play, I could make out the songs, but I could hear people talking, and I was standing near the mics. Why can't they hear what I hear? My third powerful memory of sound, I left the donut shop and worked at Mattel Toys, fixing these handheld football games. I got a job as a repair technician for consumer returns, replacing 40-pin chips that powered those things, because you needed a lot of technology in there. And I bought a 4-track recorder, and at Mattel I met a guy named Arnie, and Arnie played guitar in a band. He said, you do recording, come record, help us make a demo tape. So I go to the recording studio, and I set up the mics, I kind of figure out what I'm doing, and while I'm there, another guy shows up. His name's Tom. Tom says, hey, when you're done here, you want to see something really cool. I say, okay. So I go downstairs and knock on Tom's door when I was done. The guy's got speakers stacked he's got double 15 with these horns about this big, all Gauss loaded and phase linear amplifiers stacked up in the living room. The whole wall of the living room is nothing but speakers and a tangent mixing board, and it's reel to reel. He says, sit on the couch. I sit on the couch, and he hits play. Holy crap, it's the loudest thing I ever heard. It made those clubs. It didn't sound great. It kind of hurt my ears, but adrenaline rush, excitement. And he says, I'm trying to build some, after a while I hung out there, he said, I'm trying to build some monitors. Do you want to build some monitors with me? So, sure, I'll build some monitors. So I paid for half, and he paid for half. He taught me how to cut some wood and screw and glue some stuff together and cut circles with a router. And made some 12-inch two-way monitors with a 12 and piezo tweeters. So that's pretty much it. My fourth big memory is sound. I left Mattel and I got a job at Hughes Aircraft. I started in radar systems testing components for F-18 jets and resistors, measuring lot testing resistors, capacitors, transistors, and the such. And I got bored there, transferred into electro-optical, where I worked in the environmental test lab for TOW missile systems for the Bradley fighting vehicle. And that was cool. We got to take these rocket launchers and put them in big ovens, cook them, freeze them, put them 7 days, humidity, big hydraulic lifts, you attach them on, bang! Did it break? Let's test it. Bang! Did it break? Let's test it. And I was great because I got to correlate, and then we'd get field test units back from FMC that we'd see if our tests were aligned with the actual failures, and we'd try and recreate those failures. So trying to really get that loop closed between the end. And I learned quite a bit, and off in the corner were these amp racks, boom, 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 boom. 6 of them in a row, floor to ceiling with tube amplifiers, all wired in parallel, powering this giant shaker machine that had a piston. It was the biggest speaker I'd ever seen, except for the one next to it, which was even bigger, which had 500,000 watts of tube power amps in racks. And we'd mount a rocket launcher on there and put 400 hertz. You put your headphone. Wow, talk about the sheer energy of something so powerful, so close. And when they didn't have a device under test, one of the guys had brought in a little radio and made a mini plug to RCA adapter and ran the AM talk radio into the big 500,000 watt shaker, and that was the sound system for Hughes Aircraft. It was down in Culver City where they built the Spruce Goose, not in that building, though. PAs from the early 70s and 80s. Now, this was all about, I started in Hughes at 1980 when I was 18. PAs in the 70s and early 80s were pretty much a kludge of whatever you could find. Just thrown together stuff or something custom made by an individual sound company. There was no PAs R Us where you could go buy a big sound system like you can now from multiple manufacturers. And though they were different and each sound system had its own unique traits, they all had one thing in common. They all sounded like shit. Everyone, the whole concept, see where I'm going next. The whole concept was to make something that was extremely efficient. Power amps were expensive and heavy, boat anchor heavy, and the speakers would blow out pretty easy. Make something incredibly efficient, and then use all the technology at the time to try and make it sound good. So naturally, these things just sounded like this. And then they'd EQ them and cross them over and try and use narrow band, whatever they could do. Yet I worked in the studio, and the studio sounded great to me. You'd listen to these Uri time-aligned studio monitors, and why doesn't someone just build a PA like a giant studio monitor? seemed like a good idea. And Tom's like, no, it's never going to happen. They don't get loud enough. I'm going to build a PA like a giant studio monitor. So I got my friend Brian to help me with that, and started. That was the first PA we built. Double 18, double 12, horn. And it was a bunch of separate pieces, and we started doing shows and renting it out to some clubs. And each time I would build a PA, I'd find some problems, and then build another one, and then find some problems as the process goes. The next PA was the all-in-one box. Hey, all these separate pieces are a problem. Let's just make all-in-one. It seemed like a great idea. It sounded great in one. As soon as you put 4 or 5 or 6 or 8 together, they couldn't get out of their own way. Those 18s were always blocking. The speakers got farther apart. You had all kinds of problems. It didn't project. So then we went to this next system where we had the ability to stack them up in little lines, but it was unstable, but it was a good sounding system. And then we started going to this format that was taller and thinner. And each time working our way up to more ways. We started 18, 12, horn, and then we finally ended up with 18, double 18, double 15, double 10, 2-inch, 1-inch, 5-way system. And that was, all right, we're doing good now. And we kept building that out. And ended up building a few of those, designing the rigging systems and carrying those around the world through the early 90s. One of the problems with big sound systems, or possibly any sound systems, we noticed it when we had record players. When you set the needle down, the subs, if you had any big low speakers, they lose their mind. Well, the same thing happens with miking rock shows. Every microphone on stage, when the drummer is bouncing the stage, right, the mics are swaying in the wind, they're sending low-frequency energy. And you can high-pass this low-frequency energy to reduce it and attenuate it, but it doesn't get rid of it. So this idea of subwoofers on a separate send, what about the cannot get there from here concept, where you would just take all your subwoofers, have a separate input for those, and you just send the kick drum, bass guitar, and floor tom to the subs, and everything else goes everywhere else. Impossible for the hi-hat to get there from here. Impossible for the fan noise on the snare drum to get there from here. All of a sudden, the low end clears up. And it created another problem I'll talk about later. If that works, tweeters on an aux send. That never got as popular, but we had a 5-way system. The ends of the spectrum are always the problem. We're always striving to push audio out to the ends of the spectrum. Well, tweeters on an aux send, what are the cymbals are getting into the tom mics, and the vocal mics are picking up noise, and the stereo imaging completely collapses because everything is getting into everything. You've got 20, 30, 40 mics open on stage. What if we just ran the straight 3-way system, 15, 10, 2-inch, stereo 3-way, and then I just send the hi-hat, left and right overhead, and the lead vocal to the tweeters. Perfect, clean stereo coming out of something that extends the range, and just the kick, bass, and tom to the subs. Now all of a sudden you've got the stereo, but you've started to open up the sources where they're, not for the subs where they're, not where they're coming. And if that works, why not everything on an aux send? The Grateful Dead did it in 1974. They came from another direction. Why would we take all of our various instruments on stage and collapse them down into a PA only to be tried to maintain only to try and maintain separation again? And so they just built giant bass rigs and guitar rigs and a big vocal rig that did drums, and they set that all up behind the band. Wow, what a beautiful idea. That must have sounded amazing. So of course we had to try it on the smaller scale that we were at the time. And this is Black Flag Tour 1985 maybe. And we set everything up. It seemed like a great idea until you realize you've put the PA behind all the mics. The worst thing you can possibly do is put the PA behind the mics. So they had created out a polarity mic, so you talk into one, it would cancel out back. They went through all these extents to cancel out the problems. But when it really comes down to it, it sounds bad, having all this background noise blasting into your microphones. Not only that, our job is to connect the artist with the audience, to create as much impact as possible. And taking the PA in a club and moving it another 15 or 20 feet farther from the audience is not headed in the right direction. So all of a sudden we had this distant, far away, echoey PA, so we never did it again. Plus, where would you put the video screens? Diamonds. So I'm in Milwaukee, and it's a day off. Walking down the street, on days, I was just wandering, meandering around, and I walked by this jewelry shop. And there's a guy inside, kind of just doing his business, looking at his jewelry. And he sees me looking at him, and he waves me in. I was like, nah. No, come on in. He kind of waves me, okay. Buzzes me in. I go and say, how's it going? And he just wants to talk. Nothing. I said, I don't really want anything. He said, no, it's okay. So we chatted about some stuff. And finally, at one point I asked him, so how do you know the difference? What's the difference between a really good diamond and a really bad diamond? And he goes, I was excited to show me his craft. I love that when you ask somebody and they're interested in sharing. And so he takes out and he says, these 3 diamonds are approximately the same amount of carats and similar cuts. And I get that monocle out. He hands me the monocle, and I look at it, and the first thing I see inside of there is like this charcoal scar. It just looks like it's broken. It's so almost like so much contrast. And then there's like fractures with like haze and smoke, cracked glass inside of this thing that looks flawless from the outside. It's like, oh, yeah. He says, you see all that in there? And he describes what each of those things are. And then I look at the next one, and there's just these little tiny black specks, tiny little black dots. Barely can see them at all. I was like, oh, that's all. He goes, yeah, this is a very high-grade diamond. And I look at the third one, and I go, wow, this thing's perfect. He goes, yeah, it's a man-made diamond. It's not worth as much. So I was like, whoa. So I said, hey, so can you see, if you're like walking down the street or you're talking to someone, can you tell like if it's a real diamond or fake diamond or a good diamond? And he says, well, if I hold it and if I look at it, yeah, I can tell. With your naked eye and without looking at the glass thing? He said, yeah, I can tell. You can train your eyes to see these details over time, but to really tell, I have to use a device. So I go home, and there's something about this diamond guy. I can't get him out of my head. And I realize, like, see if I have a slide coming up. The value of flaws, the value of analog versus digital. People want digital specs look perfect or really good, and the analog specs don't look as good, but people prefer one or the other. Why do people want? The history of something has value. And digital versus analog was a big conundrum for us at the time because the early stage digital consoles were coming out, and people were saying, yeah, they don't sound good. And I was like, wow, they sure don't sound right. But then we'd get them and we'd do A/B comparisons. We'd sit there and do these blind listening tests. You hear, and it would be like wine tasting. You hear little nuances between or the variations of the 2 different consoles. Yet, when we're mixing a show, one of them sure sounded hard. The new digital console sure sounded harsher and lacking of energy. And what is it, and why can't we find it? Why can't we just go, oh, yeah, there it is? And then I thought about the magnifier. The ability to look at something and see it more clearly than you can see it with your naked eye. What if we had a magnifier for our ears, where we could hear it more clearly than we could hear it with our naked ear? Not just turning it up, and not just sitting there real quiet, but something that actually made the problems and advantage, we could see it clearly. I need one of those. How could I make one of those? I need one. I kept thinking about it, and finally when I got home from tour, I was like, John, he's our shop manager. I was like, I need a digital console, I need an analog console, I need some sources, I need pink noise, tone generator, music source, high-res DVD, CD player, and some studio monitors, some headphones, a bunch of wires, and a tech. He says, oh, what? I'll give you a tech and you figure it out. So I took the two consoles and I ran all the sources into a switcher and ran into channel 1 of both the consoles, and took the output of the consoles, ran into another switcher and ran into the headphones and monitors. I could listen to everything. And then what I did was I took channel 1 of the analog console. I went into channel 1 of the analog console and came out of channel 1 into channel 2, and out of 2 into 3, into 3 into 4, all the way up to 10. Just looped them together and set the gains. Then I went to the digital console. I went analog in, came out digital to analog, came out analog, back to D to A, to D, A to D, D to A. D. Did that 10 times on the digital console. And then I hooked up the PFL bus to the output. So then I could channel one of analog, 1 to digital. 2 channels of analog to 2 channels of digital. 1 channel of analog to 10 channels of analog. 1 channel of digital, 10 channels of digital. So what I've done is putting all the problems in series. So maybe they would highlight and exasperate them like a magnifying glass, and I'd be able to hear it. Well, first thing you notice is analog sure has a lot of hiss. It just got loud. It just gets loud. The next thing you notice is do not PFL 2 digital channels at the same time, because the latency between those 2 digital channels and the A to D, D to A flips causes this phase, and it could almost play a keyboard by hitting that thing with pink noise, getting those various tones. And then going farther into it, start to realize no 2 analog channels sound the same. It was really hard to get them all calibrated, with noise. You get them with 1 tone, you get them flat, all the same. You put another tone in, they're different. Put pink noise in, they all sound different. Digital channels, every single channel is an exact replicant of the last channel. And then finally, what I was really looking for, playing music through one, music through the other, pink noise through one, pink noise through the other. I'd always suspected those Yamaha channels were getting rid of the low end somehow. And sure enough, I could hear that in that piece of hardware, there was definitely a high-pass filter that filtered out. The low end stayed more intact in the analog console than it did in the digital. And the high-frequency sound, the cumulative D to A and A to D processing went from being subtle to quite noticeable, as well as a 2.5K harshness that was also something we had noticed. When you listen to like a 2-channel audio and you're trying to A-B 2 consoles, but in real life, you're using 40 inputs with various sources going into all the summing things, it's very difficult to A-B these pieces of hardware. And so there was my audio creation of the ×10 magnifier, which I've used since then in various ways. Comparing reproduction, excuse me. So if I was to take a photograph of this room right now with a very high resolution camera and take that photograph and print it out and put it on the wall, and then take a photograph of that photograph and print that out, all at the highest resolution I have access to, and put that on the wall, and then asked you to tell me the difference between the two by any means possible. And maybe you get the magnifying glass out and you start to look at pixel to pixel, or the distortion and measurements of the angles at the fringes and the color variations. This is actually a picture of a picture. One of them is something I downloaded a while back. The other is a picture I took of my computer screen and placed it next to it. And we can see the resolution drop should be significant here. Yet, this to me is what sound is like when we capture that room with a microphone. When in reality, what we started with was a 3-dimensional world that we locked. The first picture I took was a 3-dimensional world I can walk, live, and breathe in, and share and change perspectives. The other was a picture of a piece of paper And we're sitting here struggling with measurement equipment to tell the difference between a piece of paper and a three-dimensional environment. What is lost? How much is lost? So much is lost that it takes this measurement equipment to look at these tiny nuances, yet there's my interpretation of knowing perfect audio when you find it. When we create a recording method, a measurement microphone, something that can capture the audio of the real world in such a perfect way that when we reproduce, and we've reached transducer technology of a speaker that we can reproduce it in such a perfect way that we could play that audio track and then capture it again and play it again and capture it again and do that 10 times in a row and compare number 10 to number 1 and be stressed to tell the difference, except for maybe the mic sounds 10 times farther away. Then we will have found perfect or excellent audio reproduction methods and excellent audio capture methods. And jumping to a completely different subject. This is how I prioritize speaker designs. And I look at size, weight, maximum volume, fidelity, cost, and aesthetics. Each of these fight against each other, and we all know about these prioritizations in probably all of our fields. We all have our own set of things that we balance together. That was an abrupt change, wasn't it? Sorry about that. Let's see where we're going next. Oh, perfect audio. Perfect audio is interesting. We sit there, we capture this room, we capture all of these inputs from various sources with flawed. Why do we capture them from various sources? Why don't we put one mic up in the middle of a room? We don't put a mic up because it flattens sound out. It doesn't differentiate when we reproduce it the angle that the sound arrives from and then reproject it at that same angle or put it in the same spatial placement. So we use multiple mics to capture the spatial placement and then try and maintain that. And then we pipe it all down to the stereo paradigm. And then we splinter it all back out again and try and recreate that spatial placement that we started with before we went through 2 channels. And now we're seeing a lot more of this multi-channel, surround sound, which we actually have 2 channels, and we also have a bunch of stuff around back, but we're still stuck in this 2-channel. If I put 2 speakers in a room behind high fidelity, we take this sound system, we put a curtain in front of it, and we put a rock band in there as well. We put a curtain down, we record it. The difference between the 2, no matter how much we perfect audio reproduction, there's another dynamic, the reflections in the real world. The kick drum in a room, the sound comes off the kick drum, and that pressure wave has reflections off of the wall and off the ceiling. And the guitar, which is over here, has a whole different set of vectors and reflections. And the bass has a whole different one, the snare. And every one of them comes from a different point in space. And yet we take those and try and recreate those by radiating them from 1 point or 2 points. We try and create perfect point sources. So just as the main system developed from multi-ways, starting with the single-way wedge, the 12 and the tweeters, find out you turn up the vocals, you can get the vocals sounding reasonably good, and then you put in the guitar. Get the vocals and guitar, you get a good balance, and you put the bass in, and that sounds good by itself. Then you turn the kick drum and snare drum, you get everything good. And each one sounds good by itself. And then everything gets turned on, and everything goes in the red, you're too loud. But assuming you've kept everything at a reasonable level, this wedge is operating, this reinforcement's operating at full volume. But you can't, the singers would invariably come out. I can't hear the vocals. But you could hear them earlier until we put all the instruments in. So the instruments being added, I haven't turned them down, adding the instruments, but the vocals aren't getting quieter. They're just becoming less intelligible. And why is that? And it's pretty simple. The I am distortion component of speakers is critical and in specs under paid attention to. I don't know. If we've got a live reinforcement speaker and it's moving at the extent of its excursion, and then you've got a high frequency signal on it too, once it reaches the extent of its mechanical excursion and it's reached that limit of its electromechanical drive, and you send another signal and you say, hey, move out, move out, move out, move in, move out. And the other signal saying, hey, move in and out, move in and out. And when it gets to the end, it says, move out farther. It says, I can't. I'm already at the extent from the other one. The other guy's bothering me. I can't get out any further. And so what happens is, at the extent of the low frequency signals, blur the highs. And you can demonstrate this very easily. And we do this with wedges. We just put a low, you take a low frequency tone and you run it in there, something at the very bottom of the response of the product, and you turn it up close to its limit of volume, and then you talk in the mic. Hey, 1, 2, and you get a modulation caused by that. Well, that happens as you get these complex signals with wide bandwidth, and you're operating near maximum volumes. This blurring is significant, and so significant that, hey, let's try and solve that. The first step we did was go to 1510 tweeter. Then we went to 1510 1 inch, then 1510 2 inch, then double 1510 2 inch. With the theory of continuing, we did it with the main PA too, to get more volume and to be able to operate at higher volumes and operate farther into distortion, where you can get significant amounts of distortion into the 15s and the low frequency speakers and still keep the mids and highs clear. Why did I put this slide up? I'll look at my notes. Oh, I've been touring the world for 30 years now. We call them laps. I've probably done 25 laps, 5 of the 7 continents, and mixing sound for various countries. And it's one thing I realized, it took me a while to figure it out. I would spend all of this time trying to create worldwide sonic consistency. Yet each culture, you get to Japan, each culture's already developed its own cuisine, its own fashion, its own art, its own architecture. And I'm sitting here trying to present exactly the same audio, build a worldwide consistency in the sound I represent. I mix the band in the US, we're all good, I'm dialed in. Then we go to Japan and everybody's like, how is it? They say, too much low end, too much low end. And I look at the systems and I go out to clubs, and sure enough, there's not a proliferation of subwoofers all over the place. This is quite a few years ago. 15 years and 10 years and beyond, 15 years and beyond back. And South America, lots of subs, not a lot of highs, all kind of boomy and full. And Germany, man, pop, pop, impact. And each culture has also developed its own sonic preferences. And so I started mixing. I'd listen to the support acts, the local support acts, how they were mixing, how their engineers were mixing. I started tailoring the way I was mixing to the various countries. And for time, we have a worldwide reference point. We have Greenwich Mean Time. It's been around for quite a while. Everybody's got a watch. We have a phone. We know what time it is. But for sound, we don't really have that until something really interesting happened about 10, 12 years ago. And for the first time, there was a universal reference point for the masses where everybody, someone in Alaska and South America, everybody had turntables. We'd listen to music before then, and you had a different needle on your tone arm, on your turntable with a different amplifier, a different set of speakers in a different shaped room, and everybody bought different headphones because nothing had ever... But these little white headphones came out, and everybody could hear the same sound everywhere in the world. And as I'm traveling through this, you start to notice that this impact, you see them everywhere. You start seeing the white. And now here we are today, not only has large format sound systems, not only have large format sound systems become readily available for concerts that are also available throughout the world, but the way that I mixed, I could start to mix the same show in various countries. And the expectations from the various cultures began to rise. I couldn't get away with doing a half-assed job in South America anymore. They were... Void of albums. What happened? What have I done? So I'm walking down a path. Imagine walking down a path. And you hear sounds coming from every possible direction. You hear the wind in the trees, the crickets, every rustling your feet. Things are in this three-dimensional world. And I'm thinking about, what am I going to do? You know, always thinking about sound. And I came to this realization that, hey, nowhere in nature does the exact same sound come out of two different points in space. Doesn't happen. You don't walk down, and not only that, and when you have the exact same sound coming out of two different points in space, you have all kinds of problems and assets and issues that are created. I mean, all of a sudden now, if you have two different sounds, you have a bird and an elephant making sound at the same time, or even something that's in the same frequency range, they have no interaction. Two random pink noise sources playing at the same time, they have no interaction. But when you have the exact same sound coming out of two different points in space, all of a sudden you have to deal with time. They have to be timed perfect. You have to be distance in the physical world. You have polarity. You have phase. You have... so all these factors, and they can be used to our advantage to increase gain and directivity of sound systems, but they also can be to our detriment. I mean, you don't walk down phase. You walk down, it's like, oh, shoot, those two crickets are out of phase. I can hear a null right between them. And thinking about that further, nowhere in nature do completely unrelated sounds radiate from a single point in space. Sound of a wave, sound of a tree, sound of a goat, hole in a wall, all of it coming out. No, it doesn't. There's none of this combined. Yet we do that all the time. In fact, that's the basis of what we do. Is to create an unrealistic reality that makes no sense, like an Escher drawing. And it might be good and it might be interesting, but it's definitely not natural. And if the goal of whatever application you're working at is to have a natural sound, this is not the way to do it. So applying that back into sound systems and talking about the wedges, now we got these wedges, we turn them up, I've divided frequency, the main system's down to 5 ways. We reach the point of diminishing returns with 2 octaves per speaker approximately. And with the monitors, we've got the triamp, and getting more just becomes overly complex. What about separate inputs? So I designed the micro wedge, which was super small, coaxial, high fidelity, high volume monitor. And it's designed to separate those, put the vocals out here, put the bass here, put the guitar there, and have all those things coming from separate instruments. Turns out you can actually use less monitor system, and they don't have to be as loud because you're now using the ability of someone to be able to select and hear the localization of the sources as an advantage. All those instruments coming out of the same thing, not only IM distortion was an issue, but also localization is an issue. So I'm on a beach in Cabo. That's not Cabo. But I tried these pictures that I took. And I get a call from the manager of Chili Peppers. He says, we need to do a phone call with you and the lighting guy. Get on the phone. He says, we got to do something special for the next tour. I want you, Scott, lighting guy, to come up with something amazing. Dave, you come up with something amazing. All right? And task taken, I will see what I can do. I was at a Green Day show in a field in a big stadium, and I'm watching the show, and the lights moving, and the video, the screens come in, and there's video, and you get these different angles showing up, and it's amazing. Pyro, pop, 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 coming out. And the sound sounds great, and it's consistently blaring out of the exact same point in space the entire time. Just locked. Why can't we move? So I'm trying to think of what can I do? What's the problem? I got an idea. I'll take speakers and I'll fly them in on tracks. And have the intro music zoom out and explode into the main speakers. And it'd be, hey, that's a great idea, and it works for one shot. I can't have a gimmick. Oh, I know what I can do. I saw Rush do quadraphonic pods where they dropped them all over the thing, and the people on the floor could. What am I going to put quadraphonic on Chili Peppers? And who wants to do an effect for what I'm doing? I don't need an effect that affects this. I need to affect the entire audience. I want all 20,000 people every single night to experience something special. So what can I do? Well, unlike home hi-fi where we're constrained by the hardware, we're not as constrained by the hardware in pro audio. We have all the inputs to deal with, and we have lots of outputs, and we can put speakers kind of wherever we want, whatever the budget. This is my kick and hi-hat mix. We can put whatever the budget will allow. So what if I brought 2 PAs? Actually 3. I actually called the Pro Tools guy up. Hey, bring the Pro Tools recordings of Chili Peppers over. I bought 3 of these stereo systems because they kind of look like the line arrays we were using at the time. And I put them all in my living room on the table. And we set up a Pro Tools mix with the guitars just going to the middle speakers, and the bass just going to the inside speakers, and the vocals just going to the outside pair. So 3 pairs, 3 on each side. And then the drums were divided up with kick in one, snare in one, divided up amongst. And we set a mix up, and then we set the mix collapse down to just stereo pair, and we hit play, and this, wow. Even at short distance, even if you walked all the way across my living room and got pretty far away with these things very close, you could tell our sensitivity to hearing in the horizontal domain is absolutely phenomenal. You could tell it's coming from a slightly different area, and maybe setting up different room reflections. And then I tried it with just 2 per side instead of 3 per side, and it still worked. I put vocals in one and all the band in the rest. Wow, and so I call up Peter. I got my demo rig together. I'm all ready. I said, okay, Peter, I want to fly to New York. I got to show you what I've come up with. And he goes, yeah, I believe you. Just do whatever you want. So that's what I did. I brought in 2 of everything, 2 main PAs, 2 side hang PAs, 3 sets of pairs of center clusters, each one divided up. And not only could I put vocals, guitar, and bass, and drums in those configurations, but I could put anything anywhere in real time. I put everything. I had one group of submasters that allowed me vocals on the inside, vocals on the outside, guitar to the inside, guitar to the outside, bass in, bass out, kick, drums in, drums out. And then I had VCAs. Everything in, everything out, or whatever's, and I could do this in real time during a show. It was phenomenal. And not only that, I was able to get twice the amount of PA without getting a longer array. And I violated the #1 rule of line arrays: never put 2 side by side. But since I never put the same signal into each, there was no interference. So I was able to get twice as much line array without having the sightline issues of extending it. And L Acoustics, who designed, Christian Heil designed the system for L Acoustics that we were using. Everybody said, oh, he's going to be upset. He said, never put his line array side by side. I walked into Christian's office when I got to France. He goes, I've been waiting for someone to do this. And there's a picture of it from the mixing board. And we brought that all the way. Oh, when we get to Europe, at the end of the US tour, the manager comes up. Peter says, okay, that was fun. Now we're going to go back to normal for Europe. I said, come out to front of house today and listen. I brought everything up in the main PA. I was mixing the show. When it came out, it was all set up. I said, watch this. I'm going to go back to a normal system. And I slid the instruments into where the vocals were. And right away, the vocals went from, and we're operating these systems up at max volume, right? The vocals turned to blurry. So I boost the vocals, 3 dB, 6 dB. And now we're into limiting. Now the system doesn't sound as good as it did. And then I start to turn the instruments down. And meanwhile, he's starting to fret as the sound is just kind of falling apart. And then I take the vocals, I bring them back down, move them into their own PA, and perfect, clear and audible. And I got the PA for the rest of the world, including the stadium tour that we did afterwards. Subsequently, in future PAs, we got systems, new speaker technology allowed them to design systems that get louder. We weren't operating as close to maximum excursion and maximum volume. And the demand for this became less. We also didn't need as much PA because we could use smaller systems. So on subsequent tours, I didn't. So at the time, based on that application, this was an excellent solution. And maybe I'll do it again someday if I go back to mixing. It worked so well, U2 actually picked up the idea and did a world tour of in-the-round stadiums. I talked to Joe Herlihy and told him about my new idea about double hung PAs, and sure enough, 3 years later, they had one-upped me by having 4 double hung PAs hung around the center lobster there, whatever, crab in the middle. Subwoofer development. Subwoofer, while I'm out there, I was doing sound, I have this wonderful playground. I can test large-scale, low-frequency concepts in real-world environments on very large scale. So I can come up, hey, I want to try a sub-configuration. And these are some of the ones that I've worked on over the years. There's mainly on a Blink 182 tour, so just having a sub, an end fire system, various end fire systems. The whole goal is when we had gone to subs on an aux send, we solved one problem, but we created another one. Mono subs on an aux. So now we have that one source problem again. All the subs are coming. When we had stereo, at least we had a slightly different version of the subs coming from either side. But now we have mono subs. Mono subs is terrible unless you have a mono sub cluster, like a single sub in your house. But the problem is you have to put it in the middle of the stage. When you put it in the middle, right in front of the stage, where does all that low end go? Right back onto the band. The band hates that. Even with cardioid and direction control, having the band 5 feet away from something that has to cover 300 feet, 200 feet, is not a very easy task. So you've split the subs apart, put some subs in the middle. Now you have the problem of overlap with the 2 subarrays and the interference, the summation and cancellation patterns that occur. So now you're trying to steer these things outward, finding ways to get these subarrays to focus out and have them variable. And the one I ended up with that worked the best was this one in the bottom that says stage in the middle, which was 4 speakers. I also learned that with low frequencies, as they always told you, it doesn't matter which way they point. Well, it does matter which way they point, unless it's got a friend. If you take a sub and point it the wrong way, you'll notice it's pointed the wrong way. If you take one and point it the right way, and you point one the wrong way behind it, but you time them so they sum in the right way, 90% of everything is good, and the one pointing the wrong way is not that much of an issue. As long as does that make sense? A little bit? So in any case, once I realized that, I had the freedom to point subs in any direction and start to create these arrays. And then try them in real life, expanding out with multiple. This is the top left picture is a picture of Coachella Festival. with multiple end fires on the side. The one in the middle is pretty much an end fire arc. The two subs pointed outward and the one point in the center pointed forward with the rear one. And everything's in polarity on these, but we did some. And then the one on the bottom was the most successful. That's one of the configurations. And what it allowed me to do is in real time, or not real, I could set the delay times of that quad and actually alter the coverage depending on how wide the venue was, increase the coverage to the side, which is a big issue when you have two sources spaced a significant different distance from each other. So then I took all that PA concept and I applied it back into the wedges again. It's like, and the most recent wedge project is Super Wedge. Super Wedge is a double 12, 2-inch, double 12, 10, 2-inch quad amplified 5-way wedge with a separate amp on each channel of 2,500 watts. So it's 10,000 watts per wedge. And each of those has the ability, and there's 4 inputs and 4 outputs on the amp. And what it is a multi-configuration. You could take it and use input 1, set up the configuration. It's a tri-amp wedge, double 12, 10, 2, like a loud version of our old wedge. But if you wanted to make it a little bit better, you could actually filter one of the 12, so it did all the low mids, and the other one just did the sub, so it kind of went to a 4-way, and you got less conflicting issues between the 12s. But then you could actually run it 12, 10, 2 tri-amp and take the extra 12, use it as a subwoofer and aux send, or set it as a full range and run just the guitar into 112 and have vocals. For the guitar player, guitar into 112, 12, 10, 2 for the rest of the band. For the bass player, both 12s dedicated to bass, and the 10-2 acts as your vocal and the rest of your fill. So you have all these different configurations that are fairly easy to access. In fact, for Chili Peppers, we did that. We went one step further, replaced one of the 12s with Celestion 12s, and he had, for the first time in his musical career, his exact guitar sound showing up in the wedges. He says, Josh says to me, he says, why hasn't anyone done this before? For the first time, his guitar sounds like his guitar, and it isn't being reproduced by something with a compression driver and a woofer in it. It's coming out with all those, because it hasn't gone through the process of being mic'd, coming out of a guitar, mic'd, and the loss is incorporated there, or even coming out of a direct, but then run into something that's full range instead of limited bandwidth. Another project that I'm working on now is a new subwoofer, and it's utilizing components from a company in Italy called PowerSoft. And what that is it's a linear drive moving magnet motor that moves about 2 inches plus or minus, X max plus or minus 1 inch. And it's got flat plate paddle of moving magnets. Its magnetic force, it's got an order of magnitude more magnetic force than a single 18 cabinet. And then that's a high density polyethylene cone that you can barely move with your hand, and that thing moves it so easily it'll break your finger if you touch it while it's moving. And so the cone bolts to the motor. And that is then encased in an aluminum tube because cabinet strength becomes a big issue. It takes normal 3/4 inch plywood and moves it like rubber. And people are designed with double, 1.5 to 2 inches of plywood in order to reduce that with bracing. So I was like, forget all that. I'll just use an aluminum tube that isn't going to move at all. And slid that in and mounted the speaker in there. And those are the latest. The output of these things is phenomenal. And the frequency response, they make wind. And that pretty much brings me up to current. I think that up on a cliff there, but I think we're pretty close to question time. If anybody's interested, thank you. Thank you, Patty.
Dave, thank you very much for fascinating insight into a world we know not very much about. So I think there are a few questions. Maybe we can just take them now. That's great.
Dave, what are your thoughts on in-ear monitors compared to like the Super Wedge? I know some artists hate them, some love them. I know it's a big subject, but just real quick, what's your thoughts?
Like anything, it's a preference. What the artist wants, whatever they prefer is good. I mean, there's definitely assets and issues to both. Some of the big advantages of in-ear monitors is that it reduces hearing damage for the artists rather than these high volumes that we have to get to, or it can at least. I personally prefer, it's a tough one. For mixing out front, I love in-ear monitors because I get a much clearer signal. I don't get all that stage volume that messes everything up. For actual enjoying a show, I kind of like the live monitors where everybody's in the same space. There's some interesting dynamics. When you're on in-ears monitors, you've got the same sound no matter where you go. So the guitar player walks over to the singer walks over to the guitar player. The guitar rig doesn't get much louder. They're not able to enter various environments throughout. And I've seen that impact bands, but I've also seen them overcome it. So, I mean, to me, it's just preference.
Okay. Anybody else want to ask anything, Dave? Well, we have him here.
I'll answer anything you want. Anything that, yeah.
Okay. Okay. Well, oh, there's another one here. Oh. Karen?
So you've talked, I think, mostly about sound from an audience perspective and some about sound from a musician's perspective, which the wedge is, right? I'm wondering, like, okay, all of this is because you have to fill up a large space. Usually, I mean, you're talking about Black Flag shows, probably small spaces at first, right? What was my question? Okay, I'm a musician, and usually my favorite time is when there is no PA, and I'm in a small space, like a jazz club, and it's all acoustic. But you get in these big spaces, like how many different variables can you get with different bands and what they want to hear, acoustic instruments in particular?
Yeah, that's a challenge. And my favorite is going to a rehearsal. I mean, walking into watching like Foo Fighters or Chili Peppers rehearse in a room that's a size much bigger than a living room, that is the most thrilling, exciting, heart-stopping sound coming from each direction. As it gets bigger, the connection dissipates. And it has to be filled in with other aspects, lighting and video and pyro, and the actual, for people that truly love that musical connection, it gets diluted as the distance increases. I believe that occurs for the musician as well. They're in rehearsal, they've got everything perfect. In answer to the in-ear question, I believe that's why there's a desire to have in-ears, is they're able to maintain more of that rehearsal studio sound by being in in-ears and keep that up close and personal without having the room dynamics be such a factor. As far as acoustic instruments, doing them, I've had, when Chili Peppers first tried to put an acoustic piano on stage, everything sounds great, and then something sounds like ass. But thanks for, there's some really nice digital actual pianos are real pianos, but they also simulate digital sounds that are very, very accurate, that can be solving some of that.
Yeah. So with acoustic instruments, I mean, you've got a piece of wood vibrating, right? Whereas, I mean, you're never going to reproduce that on a speaker, I would say.
I agree. I mean, I started out what I didn't mention is I started out doing mixing big band on Sundays after church. This guy, David I. Love I Orchestra, he'd rent out this room and Mom would cook breakfast. And then I would do 60-piece orchestras. We'd do, orchestras in the park on Sunday with wine. And miking those instruments is very difficult. Now, there was an interesting experiment that Christian Heil had told me about where trying to recreate the sound of an orchestra, and instead of miking the orchestra, they mic'd each individual instrument and then took a recorded track of that instrument and then played it back through a unique speaker. And they didn't really make every speaker perfect or the same. They took almost a mishmash of arbitrary medium to high fidelity speakers and dropped a speaker in each chair and had that track played back by that speaker in that chair so that the dimension, the spatial dimension, was maintained. And I believe, my opinion is, that the spatial dimension is much more important than than it's typically accredited to be. And that you could take an analogy of having a band play with a crappy guitar rig and Kenmore amps and trash can lids and purposely down fidelity the entire process, but have it be live, or someone playing milk crates or what. And it still is live, and it sounds live, yet you could take a $100,000 stereo and do everything perfect. And in my opinion, that lo-fi band will still sound more real, and it has to do with that spatial integrity being maintained. I had one proof-ish of experiences with that. I was consulting for the design of the system we're looking at here, which is EAW Anya system. It's a steerable, so it allows you to, everything hangs straight with no curvature, and then you electronically beam steer later after the fact. It's double 15, 6 5-inch speakers, and 14 1-inch tweeters, all on separate amps, on 22 amplifiers in each box. And the real-time beam steering is able to. And so we were doing subjective listening tests, had 2 of them flown up, early prototypes, and trying to EQ it to sound right. And I carry headphones with me as a reference, and I can't get these things, they just don't, you get the tonal balance, they just don't fit. The equipment says that it's close, the frequency response says it's close, it's not fitting. So I had him bring a micro wedge out and set that down. I said, give me a physical reference. Maybe that's it. So we play the micro wedge, play it. Again, I'm struggling with the 2. And then one of the techs says, hey, hold on, let me change the dispersion of the Anya system to match the dispersion of the micro wedge. And that's 70 degrees already horizontal. So he changed the vertical to 90. He was familiar with the micro. And then the 2 started to sound the same, or at least more similar. There was a bigger change. I got closer to the sound and actually more freedom with the equalization. So the EQ became much less important once the coverage of the room was aligned with the 2 sources. So I think that, I think our ears are highly tuned to that, and that cycles back into what mics are losing, what speakers aren't doing, and what is lost in this whole process.
That's great. Gentleman over here, Carol, thank you.
So you talked earlier on about the digital versus the analog in the recording process. What is your current favorite, and why, and what do you think are kind of the minimum specs for digital that start sounding really good?
As far as specs, I just don't know. As far as preference is concerned, I mixed analog until I left Chili Peppers earlier this year. I mixed analog all the way through, and I love it. And it wasn't due to sound quality, though. Originally, it was. Initially, I did not switch to digital because of sound quality issues with digital, headroom issues, reliability issues. Over time, those 2 converged, and the digital equipment, modern digital equipment, is right there. It's better or in the same. It had to do with ergonomics and usage. A digital console's got multiple layers of page with limited amounts of faders. With an analog console, I can see everything at the same time. I have every channel. I like to focus. I turn off all the lights in the mixing board. I turn the board sideways so it's not between me and the artist, so it's off to one side. I have no riser, and I put some braille markers with gaff tape so I can slide my finger down, know what is what, and I can reach down, there's the lead vocal, run my finger up, count the knobs or feel the tall knobs, know the high mid EQ, and without losing focus, oral focus on what I'm doing and changing my perspective, I'm able to adjust the sound in real time. I'm not able to do that in a digital console, so that was my preference.
I think there's one here. Janelle?
Yeah, I had one on a question on your request for this, spatial, the spatial content of the sound quality. I mean, do you feel like you pretty much have the problem licked now and you're just fine tuning, or is there just this
Not
next
even
thing
close.
that's burning in your mind that you feel has to be achieved?
Well, I missed the end of that. I spoke. I'm sorry.
I was just curious. I mean, do you feel like you have the spatial part of reproducing the sound pretty well, that problem pretty well licked now, and it's just fine tuning, or is there this next thing burning in your mind that, man, I gotta solve this and get to the next step, get to the next level?
Yeah, I feel like just baby steps. I personally feel like we've made baby steps, and this is where audio technology is, and this is where we need to be. When you walk into a room, when's the last time you walked into a room and went, oh, wow, I thought that was a rock band. It's just some speakers. Or you actually were fooled, or you didn't have to sit there in a perfect spot, like you're placing that perfect mic and concentrate to try and force your mind to imagine. Well, you walk in, you're like, wait a minute, this has got to be a band somewhere, and you're looking. It doesn't. We're not even close, in my experience. Even with the, going to ultra hi-fi audiophile listening rooms, you're still using your imagination, and I think that. I think the breakthroughs will continue to come, and we'll get a lot closer. And as far as live audio, no, I think there'll be something, I'm not sure what it is, but there'll be more motion.
Cool. So we can take another couple of questions. I think there's one in the middle here.
Hi. That's loud. So, I agree with your quest to try to find, reproduce what is in the actual world through this, through systems to try to, objective versus subjective sound quality, right? So now we're getting into the age, and we have a lot of music that it's not really in my sphere, but things that never ever existed in air, like electronic music that has never ever seen the sound pressure waves until it reaches your speakers. And do you have any comments about how the general the way consumers consume music has gotten to the point where it's hard to have a reference point for what sounds good because it never existed in the real world to begin with. And I think, the little white earbuds that you presented have somewhat attributed it to the downfall in music quality because people don't know what to reference it to because it never existed until it hit their ears to begin with.
Yeah, that's a fascinating concept. And, it's similar to, going back to the visual analogy, it's different between someone painting a picture and taking a photograph. Whereas capturing some sort of live audio or taking some version of a photograph versus completely drawing an Escher drawing from scratch or something that has no reference to reality, and then saying, what's the best way to show this medium? And as for the electronic music, fortunately, there's a feedback loop where they're designing music for the sound systems. They're creating it to fit what it's going to be played on already, and then as the sound system develop, the music. I've done a bunch of work with Bass Nectar, and he's developing music that tracks the low notes of the sound systems available. And if the slow systems go lower, he'll design music that goes lower. So with those types of, I don't know about converging into a common on that, some sort of common piece. We did talk about. When I was young, one of the early headphones I had these Sony headphones that had earmuffs that were so soft you could barely feel them. They felt like super soft marshmallows, or even softer than that. I don't even know how to explain them. And they just rested almost airlessly on your head. And if you turn the volume up on them, you could actually feel them vibrate. And not that high of a volume. You'd actually feel them bounce on your head a little bit, moving on this kind of soft cushion. And that sensation to me was desirable. And then that made me think of and then thinking back from like butt thumpers, when now the drummers have, wedges, a subwoofer. Chad has 2 stereo super wedges and a 21-inch drum sub and 2 butt kicker butt thumpers, which sit under his seat and shake the seat as well. And then I've seen some technology, stuff where they have these vests that are like laser tag vests that add low frequency for gaming and silent discos, and just whether or not that works its way into the headphones as well with that vibration technology, maybe an EDM concept.
Great. I think we can probably take one more. Anthony.
Yeah, I just have a question. It seems that the live sound reproduction is kind of more of an art than a science. There's years and years of experimentation and perfecting it, just trial and error. Trying different speaker configurations, et cetera. But there's a kind of another world which is acoustics and field equations and maths. And do you think there's a point where those two worlds converge, to produce something that's actually better than the sum of the two parts?
That's a great question, and I didn't cover it a lot, because that's a whole other aspect. But in the mid-90s, prediction software started to show up in the audio world, in the pro audio world, and now it is the fundamental basis. So before we even go into a room, we get a 3D drawing of that environment, and then we design sound systems with load ratings, angles. We use laser rangefinders, inclinometers. Everything gets put up to exactly the right height. And before we're even in there, we already can predict how that sound will cover the room and what issues there will be. And the software is actually fairly accurate for very large spaces. And we can design rooms. And so the technology, and now they're doing long-distance sound propagation, taking environmental factors into play. So there's actually quite a bit of technology that I haven't focused on, because I figured you guys are so much better at it than I am.
Well, on that note, I'm not sure whether it's true, but on that note, I think it just remains for us to thank Dave again. We have a little presentation for him to,
All right.
a little keepsake to remind you of
All
the
right.
day. So there we go.
And thank you.
So, David's,
All right.
so we can get that shipped out to you. You don't have to take that back on the plane. But
All right.
Dave's going to be with us for the rest of the day. So do come up and have a chat. He's, as you can tell, a very approachable guy, and going to be joining us for lunch. So
Yeah, I'd love to talk about anything.
Come and
Let's talk about sound.
yeah, it's what we like to do. So thank you very much, Dave.
All right.